Jai Hind to all. I am Dr. Saroj Kushwah, Assistant Professor in Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to discuss about basic introduction of data structure. First of all, I will discuss about what do you mean by data structure. Data structure is a storage that is used to store and organize the data. It is a way of arranging data on a computer so that it can be accessed and update efficiently. Means data structure means it is a combination of two words, data plus structure. Data means raw facts and figure, and structure means organized data. It also includes the various operations performed on the data. A data structure is not only used for organizing the data, it is also used for processing, retrieving and storing data. Different basic and advanced types of data structure are used in almost every program or software system that has been developed. So, we must have good knowledge of data structure. Data structure, it is a combination of two words, data plus structure. Data means raw facts and figure. And structure means organized data. Example of organized data is dictionary, your phone book, etc. Means in your phone book or dictionary, all the words and all the contact names are organized in a ascending, descending or a alphabetical order. Data structure are an integral part of computers used for arrangement of data in a memory. They are essential for responsible for organizing, processing, accessing and storing data efficiently. But this is not all. Various types of data structure have their characteristics, features, different applications, advantages, disadvantages. So, how do you identify a data structure that is suitable for a particular task? What is meant by the term data structure? Means I have already explained about the what do you mean by data structure. Then again on next slide we will discuss about the different type of data structure. Now we discuss about the need of data structure. What are the need? What are the need and where do the data structure we use? First one, the processor speed. Second one, data search. And third one is multiple request. Because in this era, there are a lot of data generated on different sites and various organizations and wherever the work is doing in a continuous form or a estimating date. So, here we discuss about multiple needs of data structure. First one is processor need, processor speed. To handle very large amount of data, high speed processing is required. But as the data is growing day by day to the billions of files per entity, processor may fail to deal with that much amount of data. Means large amount of data to process in a minimum time is a very essential things to processing of any data. Second one is data search. To search a particular or specific data from a large amount of data is another thing which is very necessary for the researcher or a worker who want to work in this field. Consider an inventory size of 106 items in a store. If our application needs to search for a particular item, it needs to traverse 106 items. Every time result in slowing down the search process. Third, the multiple request. If thousands of users are searching the data simultaneously on a web server, then there are the chances that a very large server can be filled during this process. So, though we use the different algorithm of data structure, then we can easily find out the specific things, whatever you want to find out. Then you can get the data with a minimum time and accurate result. Next, characteristics of data structure. What are the different characteristics of data structure? Basically, we discuss about the three main things of data structure. First one is correctness, second one time complexity, and third one is space complexity. Correctness means the implementation should be implement its interface correctly. Second, time complexity. Running time or execution time of operation of data structure must be as small as possible. So, the complexity we find out the number of execution performed per second. Third, space complexity. Space complexity means to perform a large amount of data in a small space of memory. Means memory uses of data. Structure operations should be as little as possible, because multiple operations performed at the same time or stored in a memory. Next, after that we discuss about various type of data type. We have learned about data structure. Many times what happened is that people get confused between data type and data structure. So let's see the difference between data type and data structure to make it clear that how the data type is different from the data structure. Data type. Data type is a form of variable to which a value can be assigned. It defines that the particular variable will assign the value of a given data type only. Means here we assign only a one value. And in a data structure is a collection of different kind of data. That entire data can be represented using an object and can be used throughout the program. In a data type, we only use a one value. But in a data structure, there are collection of data, and collection of data represent using a object, and it can be used through the program. Second one is it can hold value but not data. Therefore, it is dataless, because dataless means hold only value. Second thing, data structure. Second, data structure. It can hold multiple types of data within a single object. Means, take an example, when we use any program using the structure, then here we can use different data type in a one object. Same here, but in a data type, we only describe or define only one single unit. What in a data structure, we define various data type in a single unit. Means you can define integer, character, float using a structure. Then there is no time complexity in case of data type. There is a single unit, then there is no complexity. And in a data structure, objects time complexity play an important role. Means how many numbers of operation perform in a one unit. Next, in case of data type, the value of data is not stored because it only represents the type of data and can be stored. Means here only define the data type. Means what type of data you will use to perform any operation. Next, in data structure, the data and its value require the space, the computer main memory. Here the space is space required in a main memory. Also data structure can hold kinds of type of data within a one single object. Next, data type example are integer, float, character, which are already defined in any computer, or header files. Data structure examples are stack, queue, and tree, where we perform different operations using a different algorithm. Here we discuss about classification of data structure. Data structure have many different use in our daily life. There are many different types of data structure that are used to different various types of problem arise in the industrial, organizational or day-by-day problems. By using data structure, one can organize and process large amount of data in a short time. Basically, data structure divided into two categories. First one is a primitive data structure and second one is the non-primitive data structure. We shortly explain, or this is a diagram, we show the different type of data structure. Basically, data structure are first of all divided into two types, primitive and non-primitive data structure. Primitive data structure again categorized into a primitive four things: integer, float, character and boolean. A non-primitive data structure categorized into a two data structure. First one is linear data structure and second one is the non-linear data structure. Linear data structure. The example of linear data structure are array, stack, queue, linked list, etc. And the non-linear data structure are tree, graph, hash table, etc. Then we define about the primitive data structure. Primitive data structure are the most basic data unit available in programming language. They include integer, float, character, string, boolean. Means primitive data structure predefined in the computer. Means there the definition of primitive data structure means integer, character, float have already defined and you can access or use this primitive data structure in a programming language such as C using a header file. Integer means it include all the positive numbers, negative and 0. Example 1, -30, 100, etc. Float means decimal number with a fractional part like 3.14, 1.0, 2.8, etc. Character, here we define individual character, for example, means all the alphabetical A, B, C, D, E, F, G up to Z, or the number 1, 2, 3, 4, 5, 6. String, string means sequence of character. Sequence of character means example hello. Next, boolean, binary value that can be either true or false, commonly used for conditional expression. Boolean value means here you have to given any data, means A, B, C, D, or in a number, and there are various operations you have to perform or you will perform to given task. Primitive data structure represent simple value that can be broken down further into a smaller component. They have a fixed size and format, and this predictably helps optimize memory uses. Primitive data types are also consistent across various programming languages. Example C, C++, Java, Python, etc. with only slight variations in naming or specific implementation. Primitive data structure. Primitive data structure are created with primitive data structure as their building blocks to efficiently organize and manage a collection of data. They can handle different types and complex operations like searching, sorting, insertion, deletion, etc. Primitive data structure fall into a two large category, linear and non-linear. Means a primitive data structure are those data structure which are used with the help of primitive data structure. Linear data structure. Linear data structure means organize the data in a sequential order. Means you have a collection of data, means raw data, then you will arrange the data in a sequential order. Example of linear data structure are array, linked list, stack and queue. Non-linear data structure. Here the data structure organize the data in a random order. In random order. Then that the data structure is called the non-linear data structure. The example of non-linear data structure are tree, graph, dictionary and heaps. Difference between linear data structure and non-linear data structure. In a linear data structure, elements are arranged sequentially, and in non-linear data structure, elements are arranged in a hierarchical arbitrary manner. Means here the elements are arranged in sequentially, and in a non-linear data structure, elements arranged in a hierarchical or arbitrary manner. Second one is the element has one processor and successor. In a linear data structure, here are one successor and one predecessor. Elements can have multiple predecessor and successor. Here is one predecessor and successor, and non-linear data structure there are multiple predecessor and successor. In a linear data structure, elements are placed at a single level, and in multiple, where we use graph and tree, there have multiple level to organize the data. Single level and here multiple level. Data can traverse in a single run. Means the data have a single level. That's why traverse in a one level, means in a single run. What in a nonlinear data structure, your data is placed at a different level. Level 1, 2, 3, 4, 5 as a tree and graph. You will see, and I will discuss in another slide. That's why linear data structure need only a single run, and a non-linear data structure need multiple run because of their level. Again, we discuss about the longer traversal times due to sequential arrangement and quick traversal due to hierarchical arrangement of data. Means quick traversal means there are the elements arranging in a different level, and longer traversal means your data arranged in a single line or a single line. That's why need a short traversal in a non-linear due to their level. And in a linear data structure, there we need only on a sequential arrangement of data and a longer traversal time. Next, memory usage is less efficient. And in a non-linear data structure, memory usage is more efficient. Means in a non-linear data structure, we use the memory or utilize the memory in a various ways. Means you can use the data or store the data wherever you find out the empty space in a memory. But in a linear data structure, you have to arrange the data in a linear order. Easier to implement. You can easy implementation of any program related to a linear data structure. But if you use the non-linear data structure, then it is difficult as compared to linear data structure. Next, the example of linear data structure means data are arranging in a linear order or in a sequential order. The non-linear data structure, the example of non-linear data structure is a tree, graph, heap, etc. Because here your data is not arranged in a linear order or in a sequential order. The linear data structure means here you have to arrange the data in linearly. Example, in a image processing, if you want to create any image, then you have to arrange every pixel in a linear order. In a non-linear data structure, non-linear, the key uses of non-linear data structure is the arranging or organizing the dictionary, computer network, and a priority queue. In a priority queue, where all the elements arranged in a queue based on their priority. The elements which have more priority fixed in or stored in memory first, wherever you find out the space. The description of linear and non-linear data structure. Array. First of all, discuss about array. Then, what do you mean by array? It is a basic topic and very important topic to arranging a large amount of data. If you want to arrange a large amount of data, example, create a student list, their roll numbers and subject. At that time, we use array. Array is a linear data structure and it is a collection of items stored in a contiguous memory location. Means whatever the item you want to store in an array, then you store at a continuous memory location. Means one by one. one by one arrangement of data in a sequential order. The idea is to store multiple items of a same type together in one place. It allows the processing of large amount of data is a relatively short period. You can arrange the number of data means a wide amount of data in a short period. First element of the array is indexed by a subscript of 0, means basically or whenever you use to perform any operation using the C, then indexing start from the 0. There are different operations possible in array like searching, sorting, inserting, traversing, reversing and deleting. Sorting means to arrange the data in a ascending or a descending order. Inserting means you input or to insert our data in array. Traversing means you can traverse or visit each and every element, the data whatever you insert. Reversing means you look the data in a reverse order. Deleting, here we delete the item from a program or an element, whatever the element we want to delete. Here the representation of array, memory location in this array to 200, 201, 202, 203, these all are memory location of element, and 0, 1, 2, 3, 4, 5, 6, it is the index of the element U, V, F, D, A, E, C. The U, V, we called it is item, data item or element simple. Linked list. A linked list is a linear data structure in which elements are not stored in a contiguous memory allocation. The elements in a linked list are linked using pointer as shown in below image. Means here the in this field we call the data in a linked list, and here we store the link, and all the elements stored in this node. We called it node, and node are divided into two fields. First one is data field and this one is link, or you can say address field or next. This field store the address of next element. Suppose the address of this node is 200, 201, 202, 203. Then the first node always contain the address of next node. Means here store the 201, and this field means this field contain the address of next node. There are different types of linked list. Basically here we discuss about the 4 types of linked list. First one, singly linked list, next doubly linked list, circular linked list and doubly circular linked list. The most important type of linked list are doubly linked list, circular linked list. But doubly circular linked list is a more important than a circular linked list. Stack. Stack is a linear data structure that follow a particular order in which operations are performed. The order is LIFO. LIFO means last in, first out, or you can say that last in, first serve. Entering and retrieving the data is possibly from only one end. The entering and retrieving of data is also called the push and pause operation in a stack. Push operation means insertion of data in a stack, and pop operation means deleting the data from a stack based on last in, first out. Whatever the element you have inserted in a last, it delete at a first. Then different example of stack you can see in a number of plates arranged in a hotels or a party in a different places you can see, and different operations and applications where the stack is used is recursion, sorting, deleting, etc. Here the stack is also used to perform the operations using a tower of NOA, Fibonacci series, and convert infix to prefix, prefix to infix, etc. This is the figure of stack where the different operations means here only two operations perform, push and pop. Pop means deleting the data item. Here A, B, C. Now C, after that B element delete B and then delete A. It follow the FIFO. FIFO means whatever the element, insert at the first, insert at the last, then delete at first. Insert, last and delete first. Stack means FIFO. Insert first element, keep at bottom. All the operations means push and pop. All the operation performed at the top of the stack. You cannot perform any operations at the mid. You have to perform all the operations at the top of the stack. If you want to insert any item into a stack, then from the top, at the top. And if you want to delete the item, you have to delete from the top, not at the mid. Queue. It is also a linear data structure. But the order of queue is first in, first out, first come, first serve. Operation performed linear data structure. Follow the FIFO, first in, first out. Example means bus stand. If you standing at the bus stand, then you enter the bus at the first. Or customer care, the number of consumers continue calling at a one time, then all the calls arranged at a FIFO order, means whoever the user call first, then arrange in a first order. The data item stored first will accessed first. In this, entering and retrieving data is not done from only one end. The example of queue is any queue of a consumer for a resource where the consumer that came first is served first. Different operations performed on queue, like reversing a queue with or without using recursing, reversing the first k element of queue, etc. A few basic operations performed in queue. Here is the pictorial representation of simple queue. This is the front end and this is the back end. We also called front end as a head and back end as a rear or tail. If you want to delete any item from the queue, then you always use the front end. Means you have to delete any item only a front end. If you want to insert, then you insert only using the rear end. Means the item 8, 7, 6, 5 and 4. Inserted, have we inserted using the rear end. Tree. It is a non-linear data structure, or you can also called as a hierarchical data structure, where the elements are arranged a tree-like structure. In a tree, the topmost node, also called the root node, the node contains some data, and data can be of any type. It consists of central node, structure node, sub node, which are connected by edges. Different tree data structure allow quicker and easier access to the data. It is non-linear data structure, and the tree has used various terminology like root, node, edges, height, etc. There are different types of tree like binary tree, binary search tree, balanced tree, ABL tree, also called the balanced tree, B tree, B plus tree, etc. This is a figure of tree. The first node we call the root node. The root node have different children, one or more, or 0 children also. It is a root node is a parent of all the nodes. It is divided into a 2 subpart. If you want to, then this is a left subtree of this node and this is a right subtree of this node. There are different level, means at a root level you will start level 0, 1, 2, 3, and it also represent the height of the tree. Then this node is a parent of these nodes 6, 7, 8, 9, 10, and 5 node is a parent of 11, 12 and 13 nodes. Level 3, at the level 3, all the nodes we call the leaf node, and 6, 14, 15, 16, 17, 18, 19, these all are called the leaf node of their previous previous nodes. Previous nodes means previous nodes of 6 is 2. Just the lines, we called it branch of node or edges. Two, 3, 4, 5, 6, 7, 8, 9, 10. These are data and element you have stored using a tree. Graph. Graph is a non-linear data structure and consists of vertex of node and edges. It consists of finite set of vertex and set of edges that connect a pair of nodes. The graph is used to solve most challenging and complex programming problems. It has different terminologies which are path, degree, adjacent, vertex, connected, component, etc. Means graph, non-linear data structure. Why? Because nodes are not arranged in a sequential order or at a one level, single level. Here all the data means 0, 1, 2, 3, 4, 5, 6. It is arranged at a different level. Mean different terminology. Here different terminology which are path, degree means the path means 0 to 1, 1 to 3, 3 to 4. These all represent the path. Means 0 to 1 path, 1 to 2 path, 2 to 3 path and 3 to 4th path. The line between 4 to 0 we call the edges, edge of graph. Advantages of data structure. Why do we use? Means what are the different advantages of data structure? Improve the data organization and storage capacity. If any organization or anyone want to use data structure, because of improve the storage capacity, means here are different operations use, such as using a tree, graph. Here you storage means you can storage or fully utilization of memory. Second, faster data retrieval. There are different sorting use to retrieve the data or operation performed to retrieve the data, very less time. Facilitate the design of algorithm for solving the complex problem. Data structure is mainly used to solve any problem using the algorithms. Means here most of the time use the algorithm. Easier the task and updating and maintaining the data, providing a better understanding and relationship between the data elements. Here the data means example, the means providing the relationship, means the relation between using a tree, parent node to the sub siblings node or child node, or using the graph, the 0 node connect to a 1 node. Disadvantages: increased computational and memory overhead, difficult in designing, then it is not a typical, very typical, but less. Difficult designing and implementation, complex data structure. Limited scalability and flexibility, complexity in debugging and testing, difficult in modifying existing data structure. If you want to delete the data, whatever you insert in a memory previously, then if you want to delete, then there are different operations performed to delete the data system, then insert, then again set up the data in a same algorithm. So it is complex, and testing is also complex. Thank you.